I'm automating all Mario Party DS games with computer vision algorithms. My goal is to create the ultimate Mario Party AI bot that can play and win a full game and all mini games. But we have quite a few games left to go, so let's get started. Press for Success is a game where you have to keep track of a card while it's being shuffled. There are 4 cards in total and you have to pick the correct one that matches the character's outfit. After 3 rounds, whoever got the most points wins. And I don't know if I'm getting old, you guys, but sometimes it was kinda hard for me to follow. But of course, I don't have to use my eyes, I can write code to beat this game for me. You may think that in order to win, you need complex motion tracking of all of the cards, but there is an easier way. One crucial detail is that only 2 cards leave their place at any one time. So while it looks like a mess, if you slow the game down a lot, you see that all cards return to the slots before starting the next swap. And we will abuse this fact to very easily keep track of what's going on. I picked 4 pixel positions to watch for, 1 for each of the cards. I also created a list that stores the current ordering of the indices. Every frame I'm looking at the color values of the 4 tracker points. Since the cards have the RGB color value 251, 251, 251, I know that 2 of them are being swapped when the respective tracking locations have a different color. So for example here, all trackers are white, and here 2 of the cards started moving, so the color changed and we know that it's these 2 that I need to swap in the list. And that's it. If we know which card index is the correct one, we can see where it is at the end.
Wait. What the hell?
Wait a moment. That didn't work as well as expected. Well, after a bit of debugging, I stumbled upon this behavior. When pausing the emulator mid-swap, you can see that the algorithm keeps logging swaps, even though nothing is happening in the game. And it makes sense. My rule was, when 2 pixels are not white, log them as swapped. But this rule runs every frame. So basically, on every swap, we have a 50% chance of logging the correct result. Of course, this can easily be mitigated by adding another guard clause. We only want to track a swap after the previous one has been completed, or in other words, all 4 cards return to the initial resting position. And that's the condition we need. After a swap was detected, all 4 trackers must become white again before another swap can be registered. I also added some simple logic to react to the general game state. When exactly 3 trackers are white, we know the game is about to start and the missing index is our target card. Then, when all trackers are white after that, the game has officially started. And finally, if all 4 trackers are white and nothing happens for a short while, the round is over and we pick the card that corresponds to the target index. Let's see how it goes. Yep, that's what I was going for. I think this game was one of my favorites to automate, because it seems complicated, but the solution is pretty simple. And if you made it this far, here's a little game for you to play. If you pick the wrong card, you have to subscribe. Oh, and if you picked correctly, you have to like and subscribe. YouTube also has this new hype feature for small creators, so if you want to help me reach more people and produce even more videos, click that new hype button. You can do it up to 3 times. If it doesn't show up for you, it's probably not available yet in your country, it's just being rolled out right now. Let's see what's next. Crater Crawl is a 4-player survival game in which the sick game makers put you into an active and violent volcano and you have to climb for your life. You can move around the rim of the volcano and have to dodge lava geysers that eliminate you after bubbling for a short moment. You can also climb over other players momentarily by spamming the A button, but you don't arrive at the top any faster. To solve this game, we basically need two things: the player position and the position of any upcoming lava geyser. Finding the player is rather easy with the OpenCV in-range function, with which we can look for purple color in the image. Getting the geysers is a bit harder though. Before one comes up, some lava bubbles appear, and that's when you already have to start moving out of the way. Now, luckily the bubbles are a bit brighter than the rest of the lava, so we can again use the in-range function to find them. Because there are usually multiple bubbles at the same time, we take the mean X and Y positions of all of them to get the rough center of the upcoming geyser. Right, now we know where the player is and where a geyser will appear. And since we're moving in a circle, you guessed it, we're going to use polar coordinates again. I will reuse my conversion function from earlier episodes that takes an X and Y pixel position and returns the distance from the origin and the angle. The distance is irrelevant for this game, since all players and geysers are always equally far away. Now we can use the angular difference of player and geyser to determine in which direction we have to move. If it's greater than 0, we move left and otherwise right. Now, we should have enough logic put together for a first test run, but it's not quite enough to always win. As you can see, the bot struggles when the bubbles are close to the player, and it would struggle even more later in the game with multiple active geysers. To fix this, we store not only the position of the bubbles, but also the timestamp when they first appear. From the moment the first bubble appears to the time where the geyser is fully gone, it takes about 3 seconds. So instead of checking every frame if there are any bubbles, we establish a sort of no-go zone that is active for 3 seconds and move away from that. In fact, while one no-go zone is active, more bubbles can appear in a different location, so we really need to keep a list of no-go zones, including their position and time information. It sounds complicated, but the changes to the code were rather straightforward. Oh yeah, and I added a constant A button spam to easily move over other players without getting stuck. Let's see if this is enough. Yeah, looks like we got it this time. And before we go to the next minigame, shout out to Punk, who randomly spotted me in the Lo-Fi Girl live chat. I was just testing a chat scraper for a different project when I got tagged out of nowhere. Anyway, time for another 3 vs 1 minigame. Let's take a look at the team version first. In Gusty Blizzard, you have to rub over your character to keep them warm. The faster you rub, the less frozen you get. Funnily enough, I was able to just reuse the exact same code I had in Cucumber Jacks. All I had to do was change the 2 points for the mouse positions, everything else can literally stay untouched. If you haven't watched the last video, first of all, you definitely should, but how it works is I'm dragging the mouse from one point to another and back again. I also added interpolated midpoints on the way to make the movement seem more natural to the game's logic. It really doesn't like it when you just teleport from one point to another on the touchscreen. Anyway, here goes. Yep, looks like we never dip far below the initial temperature, so this game is pretty much solved. And finally, the single player mode. To win, you have to blow into the microphone to freeze your 3 opponents. The harder you blow, the more they freeze. In the emulator I'm using, Melon DS, you can select a sound file that plays into the virtual microphone when you hold the respective button. And that's how we can control the input. If you watched my big blowout video, you may get PTSD from what's about to happen, so here goes.
Scimpanzini bananini. Trallallero trallallà. Bombardiro crocodilo. Tung 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 sahur. Brr brr patapim.
Even the expert gets frozen, but just barely. I mean, you literally can't do better than this, so that's a pretty strong opponent. And that's it for today. Thank you for sticking around until the end, and make sure you subscribe for more videos like this. See you in the next one.